Welcome back, everybody. I'd like to again thank our connecting industry partners and sponsors, Job Skills Network, the Industry Capability Network, Industry Queensland and LinkedIn. Right now, we're going to hear from QEM Limited, and I'd like to welcome the Managing Director, Gavin Loyden, to the stage. Gavin is the founder and Managing Director of QEM Limited, having identified and acquired the significant dual commodity resource at Julia Creek. As such, he's responsible for QEM's capitalisation, exploration program and development of QEM's flagship vanadium and oil shale project. QEM Limited is a publicly listed company focused on exploration and development of its flagship Julia Creek project, covering 250 square kilometres in the Julia Creek area of northwestern Queensland. The Julia Creek Vanadium and Oil Shale project is a unique, world-class resource with the potential to utilise and deliver innovative and sustainable energy solutions through the production of energy fuels and vanadium pentoxide. QEM strives to become a leading producer of liquid fuels in response to a global vanadium deficit, and also aims to become a global supplier of high-quality vanadium pentoxide to both the nascent energy storage sector of the Australian steel industry. Please welcome QEM Limited Managing Director, Gavin Loyden, to the stage.
Thank you for the introduction, Nicola, and thank you for the invite today. I'd like to present the Julia Creek project that we have up in northwest Queensland. I'll go through there will be some forward-looking statements, so we have a disclaimer there that I'm sure people are aware of, and this will be available on the site.
Okay, so, ready to share screen, please, Gavin?
Is that not sharing?
Not at this point, no, I'm sorry.
Okay, just give me 1 second. Forgive me. Here we go. Okay,
perfect.
How are we going there?
That's perfect, thank you.
Terrific. I'll just run through that again. There's our disclaimer, and on to the next slide. QEM is focused on the exploration and development of the Julia Creek project that you rightly pointed out. We are looking at doing a multi-commodity project there in Julia Creek. We're focused on vanadium as well as the transport fuels that can be attained from the resource, which is an oil shale resource. So we're looking at those two product lines. Sovereign supply is what we're looking at. This is not necessarily an export project at this point in time. We're looking at fuel security here in Australia and high purity V2O5 for battery electrolyte for the stabilisation of the grid and the help and the assistance in the rollout of the renewable energy projects that Queensland and Australia is involved in. So if we look to the board, we've got a highly respected team with great credentials across both those commodity sectors. Tim Wall is our chair. Tim has been an executive in multiple ASX 100 companies. Our keen interest, of course, is in his former managing director role with BP Refinery at Bulwer. He is an expert in that space. He's one of the senior advisors on oil and gas to DSS Plus, and interestingly, a former global president for manufacturing for Incitec Pivot. And then we have Daniel Harris, and Daniel's probably one of the foremost experts in vanadium globally, over 45 years now experience in the vanadium sector, and has literally walked every project on the planet. So no one knows anything more about vanadium than Daniel Harris. Daniel also sits on the board of Australian Vanadium in WA, and is a former director of US Vanadium. He lives over in the US. He's the interim CEO for Atlas Iron, and most importantly, ex-global VP for Evraz in their vanadium division. Then there's myself. I'm the founder of the company. As you mentioned, I'm developing this project. We've also got Tony Pearson. Tony's an ex-MD of HSBC in Hong Kong. And David Fitch is been along this journey from a very early stage. David's a high net worth individual and has seen the opportunity here and continues to support the company very strongly as we move forward. Quick corporate snapshot, very tightly held company. Over 72% of the company is still held in the top 20 shareholders. We've only got 151.4 million shares on issue. You can see our share price there just from a couple of days ago, running about 15 cents. You can see it's quite a lateral movement across the share price there. But if you look at our market cap of being about $22.7 million at the moment, it's a highly undervalued project at the moment, and I think you'll understand why as we move forward. Now, let's talk a little bit about vanadium and where it's sourced. There's two distinct resource bodies here in Australia. One is here in Queensland, which you can see there is from an oil shale deposit. So that's a sedimentary deposit. And in Western Australia, it's in magnetite. So basically in an iron ore, which has traditionally been sent to China, and the vanadium is processed out of the steel-making process. We've got about 31% of the global resource of vanadium in Australia, and yet no one's actually mining just yet, although there's a few proposals coming up, as you can see the dots on the map there. That places us now as number 2 in the world for vanadium resource, just behind China. And that is something that gives us a great advantage in the resource space. We'll go on now to talk about some of the uses of vanadium, because some of the audience may not be aware. It's probably the world's most versatile metal. It's primarily used in steel strengthening, and in fact Henry Ford was the first to use it industrially in his Model T Fords, and that's why some of those chassis are still getting about, because it adds to fuel efficiency, because you're lightening the vehicle, you're certainly strengthening the vehicle, and it's got great weatherability. It also reduces emissions in the actual production of steel. So all of your high-speed tooling, vehicles in the chassis, bridges, tunnels, anything that goes aerospace. So it's critical in the aerospace sector. You need between 5 and 15% vanadium in the alloys, and that's what prevents that meltdown at super high speeds. So anything that goes supersonic speed needs to have vanadium. It's irreplaceable in that space. So these are existing markets that drive vanadium at the moment. Sulfuric acid catalysts, smart glass, it creates the tinting in smart glass because it's heat reactive. But the most important part for us, and certainly for Australia, I believe, is in the renewable energy sector. So vanadium redox flow batteries are really well suited for grid support. And as we roll out through the energy transition, that's going to become more and more important, and I think this is why, particularly in Queensland, the government has already recognised that the vanadium is probably the way forward for these grid-scale support systems. The reasons behind that is really about the durability of these systems, their applicability to Australian conditions. They don't distort in high temperature or low temperature. There's a comparison here, as you can see, with lithium. Don't be distracted by the shape of those batteries. That's not exactly what they look like. But it certainly gives you an idea of this being a flow battery as opposed to a solid state battery. So very long lifetimes in comparison with lithium between 3,000 and 10,000 cycles. Vanadium, hundreds of thousands of cycles, as a matter of fact. They have a low discharge rate, so once they're charged through renewable energy, they stay charged. They don't have much energy leakage. They're long duration storage batteries, so this is a distinction. So this is 8 hours plus. In fact, they're getting up to about 24 hours now. So again, that provides that ability to react into the grid and maintain that energy release over a longer duration of time, and you can discharge and recharge the battery at the same time. So it's quite unique in that space. Most importantly, they're safe. They're a flow battery. They're liquid. They can't catch on fire. They're fully recyclable. They've got lower operating costs over the duration or the lifetime of the battery, and they have a reasonably similar footprint to lithium batteries because of the scale of those systems. So very, very interesting concept, and this, well, beyond concept, it's actually enjoying its 40th year now. This is a battery that was invented in Australia back at the University of New South Wales back in the early 80s. Professor Maria Skylos-Kazakos, still working on this today at the university and working on improvements in iterations all of the time, and that's just making the energy density of these systems better. The amount of vanadium going in there is reducing. So really, she's done a fantastic job, but it's not a new technology. It's been rolled out around the world now and starting to gain real traction. There's over 300 projects globally. So they're not a new invention. They're 10 years older than lithium batteries, as a matter of fact. So you'll see here in this graph the IMF predictions of an 8-fold surge in vanadium demand by 2050. So that's in the vanadium metal itself. And you can see that vanadium now sits at number 2 on that list. So it's currently, close to a $2 billion market at the moment, but that's going to grow significantly. And the demand is expected to be, 25% of the actual market as we move forward. You'll see there it's only 118,000 tonnes thereabouts of vanadium metal. That translates to about 200,000 tonnes, give or take, of V2O5, which is the actual oxidation level that's required for these batteries. So the growth in the vanadium sector is about 200% by 2050, and that's coming from the World Bank. But the growth in the actual batteries itself, between 20 and 40% growth year on year, depending on which pundit you listen to. I'll take any of those growth figures because they're quite spectacular at the moment. The World Bank just put out a document just a couple of weeks ago speaking to the ability of vanadium to do this task at a global level and the availability of vanadium here in Australia to do that job. So it's a very exciting space to be in. Now, the project itself, we're in a tier 1 jurisdiction up there in the Northwest Minerals province of Queensland. The project covers 250 square kilometres. We just recently finished another drilling program, and you can see there's a concentration there on that map or in that tenement section where we've looked at the lowest stripping ratio for this project, and that's where the main pit shells will be. We're working through our scoping study, which is just in the final iterations now, so we'll have that out in the next few weeks. So this is one of the largest global resources for vanadium that's in one line. So everything runs laterally across that entire project area. You can see where we've got a green line of economic limits in both the left-hand corner of the tenement as well as over in the right-hand section of the tenement area. That's the economic limits of this project. That's 250 square kilometres, all of which, apart from about 7%, is economic. So it really is a big, large resource. You'll see those seismic lines that we've done there, as well as looking at the fracture points, which don't have any issue for us in the mining space. So there's no issues with faulting. It's very minimal, and as I say, it's quite contiguous across the entire area. So as I mentioned, we're looking at creating at least 2 products out of this and potentially more, but we're focused more on the fuel production as well as the vanadium. And the reason being, we are out of liquid fuels in Australia. We're importing about 93% thereabouts at the moment. That's adding about $30 billion to our trade deficit. We've gone from being a net exporter of oil and oil products down to a net importer of products. We had, 10 years ago, we had 7 refineries in Australia. We are down to 2 at the moment. And we're getting most of our fuels, liquid fuels, from Malaysia, all of our aviation fuel from South Korea, and 25% of our liquid fuels coming from China. So that's leaving us a little bit exposed. I think COVID showed our lack of resilience in this space, and that's certainly becoming an issue for national security now, as geopolitical tensions start to rise. We are the only member of the International Energy Agency that is non-compliant in our 90-day supply agreement, which means we are supposed to hold a 90-day strategic reserve of fuels at all times. And we haven't done that since, I think, 2013 or 2012. So, and as I say, we're the only country in the world that's a signatory to that International Energy Agency agreement that is non-compliant. And that really exposes the risks. The whole issue that we've had of this on-time delivery and counting ships on the water as reserves of fuel, that's very, very hairy position to be in. But it's something we see as an opportunity. When we're talking about fuel, we are only talking about being regionally significant for fuel production, but globally significant for vanadium production. But this is something that we need. There's no domestic production at the moment apart from condensates from the gas industry, and all of that has to go offshore to be processed. We don't have that capacity here in Australia. The two refineries that are left, very old. They're not set up for that work. Now, how are we going to do all this? Well, interestingly, we're going to be using renewable power. So we designed a project some time ago, and I'll get into that a little bit more in a moment, for a gigawatt renewables project. And that's because we needed quite a bit of green hydrogen in this project to extract the oil. We've developed a unique process for this oil extraction, so it's not a retort. It's a closed loop supercritical process whereby we use green hydrogen, turn that into a hydrogen donor solvent. We then put our oil concentrate into that facility, and the hydrogen actually gets donated toward the hydrocarbon chain, and that in effect gives us a 1.8 times uplift in what the measurement of oil in situ is today. And that's done through what's called a modified Fischer assay. It's a little bit of an old way of doing it, which is basically a retort, an oven. They cook the shale up, the gases come out, it's reconstituted as an oil, and that's your litres per tonne. As I say, a little bit old way of doing it, but we're getting consistently in our pilot plant 1.8 times that number. So in our case, you're talking 70, 80 litres a tonne in situ via an MFA. We're getting 140, 150 out of that. So it's quite a good way of doing it, and it's a closed system. So environmentally, it works. Then we secondarily use more green hydrogen to hydrotreat that and turn it into a product. And our goal here is low sulphur diesel fuel. Now, if we go back to the top of the flow sheet there, it's a shallow open pit mine. We're talking between 35 and 50 metres to the top of the shale. We then separate the limestone out in a beneficiation process. The kerogen, which is the oil component, is floated off and goes in one direction through the oil extraction process, and then the separated solids are further beneficiated, further removing calcation and flotation, because the vanadium itself is contained in the finer clays. That's going to give us, in our scoping study, around about 11,000 tonnes of high purity V2O5 a year. You've got those other market verticals there, but we are really focused on vanadium redox flow batteries. And the reason being, we have a great need for that in the system just here in Queensland, but certainly Australia-wide. Here in Queensland, I think the latest number is about 24 gigawatt hours of storage. To put that in some context, rough numbers, you're looking at about 10,000 tonnes of vanadium per gigawatt hour of storage. So it's quite a substantive problem in front of us, and we're hoping to address that in the very near future. There are other opportunities that we've just put in a dotted line there. There's some, there's some aluminium in there that we haven't done that work yet, so we've just left that to one side. And the material at the end of this process is well suited to Portland cement, but again, we need to finalise that work before we put that into our flow sheet. So we've left them out of the equation at the moment. Now, obviously, when you're looking at doing oil production in Australia, or anywhere for that matter, you really want to be as green and efficient as you possibly can. I think that's what we're trying to achieve here in this project. And as I mentioned earlier, we designed a large-scale, gigawatt-scale renewables project, primarily wind, with some solar and battery backup. what you're seeing on the screen there is just an indicative layout of what we considered to be appropriate. We did a study with GHD where we did pre-feasibility work, and that's what you're seeing there. And that's, we're right on the copper string line, and that's where this became interesting. So what we did is we packaged this up, and we put a met mast out there in 2022 to measure the wind speeds. We put solar and SODAR and dust measuring equipment out there at the same time, because a developer would need that information to move forward to any decision around a project. So we did that. We got about 18 months of data, and then we put that out to a number of companies. We had about 15. We whittled that down to 3, being Origin Energy, NL Green Power Australia, and Acciona. And we ended up going with NL Green Power, and they're one of the largest wind developers globally, $155 billion company. NL Green Power Australia is a joint venture between NL and INPEX, the Japanese gas company. So they are now doing that project, and we're very excited about that. The goal for us was to get some cheap power, behind the meter power. We've managed to do that through this project, and that allows us to give a defined power consumption and power cost for us in our study program, which is quite unique. Otherwise, you just don't know what the price of power is in 10 years, but we certainly do. And we actually got paid for the sale of the assets of that project as well, so that's setting us up quite well. There's some other interim payments that will come along to us as the project develops. So nice to take quite a large-scale problem that we had and turn that into an asset. So if we look at the government support around battery development here in Queensland, and you'll see in the latest budget that there's a great deal of support. And the reason we find this interesting is because the state owns the grid here in Queensland. They will be purchasing these batteries. So it's quite a neat fit for where we are, and particularly in North Queensland. We've had support for the Queensland Resources Common User Facility, which is a $75 million project that the government is producing for us in Townsville, whereby we will be able to do further testing and scaling of this project up to demonstration scale, so out of the lab and into demonstration scale. That's available to the vanadium industry as a whole, and then further be expanded into further critical minerals development. So great support from government, and federally similar. So there's a lot of movement in this space, and for very good reasons. They've set targets that need to be addressed, and this is the way to do it. We've also got a small sideline project where we've been collecting the spent catalyst from the sulfuric acid industry here in Queensland. So we were the first to produce vanadium pentoxide here in Queensland, and that's the orange material you see there. So we got a 99.93% vanadium pentoxide basically on our first pass. So this is unoptimised. Now we move toward the next scale of optimising this project and then getting some further material, and then that will be something we can present to battery companies as well. So very exciting little project, and we're very successful in that one, and happy to be the first ones to ever produce vanadium from an industrial waste stream. So it's a great circular economy project. ESG has always been a keen focus of ours, and we continue to report on that on a quarterly basis. We use Social Suite as the platform for that, which means we need to improve on our metrics as we move forward on the project, and that's measured and by Social Suite and then reported on in our quarterlies. In a timeline, we're looking to have this project developed around about 2027-28 with production in 2029. That'll match the delivery of Copper String and the renewables project for those dates in Julia Creek. So we are constrained a little bit by power, and the other thing is water, so we're working on that with the government right now. Some of our development partners, and they've been fantastic along the way, and we'll continue to work with these guys. That's the opening of our office out at Julia Creek, so we do have a presence out there. And that's pretty much it for me in the presentation. So thanks very much for listening.
Thanks so much, Gavin. It's such an interesting project, and I'm fascinated by how you can create a commodity, a valuable commodity and resource from industrial waste.
Yeah, it's pretty exciting, and it's something that we can expand on as we go. We'll get this test work, scale-up test work at the next level completed, and then we'll be sourcing a bit more of this material, and hopefully we'll be the first ones to get some electrolyte into batteries as well.
I've got one quick technical question that's come through on our comments screen. Are you able to tell us what depth you have to mine to reach shale, and what depth does the shale go to?
Yeah, so in that first pit shell, we've got over 30 years of resource just in the first pit shell. There's a potential for 3. So there's over 100 years of mining. But to answer your question, the resource starts at about 35 metres and averages 55 metres in that first pit shell. So that's to the top of the resource.
Wow, that's incredible. And I was looking at the schematics earlier on in your presentation. The share price is currently sitting at 15 cents. Now's the time to get on board.
Correct. We have over 700 million barrels of in situ oil. We have the world's largest vanadium resource, and we're getting zero valuation for it at the moment. But hopefully that'll change as we start to put out further numbers in our scoping study, and obviously beyond that to our feasibility work, which will be quite a shortened piece of work in the scheme of things, because we've already built pilot plants. We've already, all of the work that goes into this scoping study is pretty close to PFS work. It's based on our own research. It's based on our own results from testing of the last 4 years of testing. So it'll be a scoping study on steroids, but that'll shorten the process for us in the PFS. So I think that gives us great advantage.
Do you think that low valuation is maybe a lack of understanding of the project and what its overall capacity is once you realise this?
Look, I think that's very true. And, the last few years have been very much an education of both government and the market in vanadium, because it's quite novel in Australia. No one really had any understanding of it. In fact, it's been a process, but we're certainly getting there. It's certainly at government level, they've understood now and see the size of the opportunity and the immediacy of it. So that's really, really helped us. And very importantly, the amount of skill set that's come onto this in the last 5 years. I've been doing this quite some time, and we had to do work overseas because no one really had the capacity here in Australia. But in the last 4 or 5 years, the brains trust from every university and every institution has been thrown on this, and it's really resulted in some fantastic results. What we were doing 5 years ago is not what we're doing today, and that's because of people like the SMI at UQ, the Chem department, and others, and everyone's pulling in the same direction, and that's why we can be quite collaborative with the other vanadium producers up there. It's a large problem that we've got. It's a large gap to fill, and there's plenty of room for everybody in that space.
And you've got such an experienced team. I'm sure that there's nothing but success coming your way.
Yes, exactly. They have very strong reputations, and they don't like to put that at risk for any reason. So
well, if that's not encouraging.
That's
Absolutely.
Yeah.
Gavin, thank you so much for your presentation today. I'm going to ask you to head over to the booth. If anyone would like to talk to Gavin and learn more about the Julia Creek Vanadium and Oil Shale project, Gavin will be available at the QEM booth now. So head to the QEM booth, take your seat. Gavin would love to talk to you about all things vanadium manufacturing and all of the exciting things that are on the scope in the next couple of years. And I'm looking forward to watching this space with you, Gavin. Thank you so much.
Thank you so much, Nicola. Great to see you.